Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
Okay, let's do some electrostatics. So, first question. A child rubs a balloon on their jumper and then brings it near a thin stream of water out of the tap. The water bends towards the balloon. Explain in terms of static electricity. So, first thing that you need to state here is the idea that you have electrons, those are your charges, that are being transferred between those two things, the balloon and the jumper, via friction when you rub those two things together. Via friction, really important, and the idea of electrons transferred from one to the other, also really important. So then you could say that one of them receives excess electrons, so takes on that negative charge and becomes negative charge, and one of them loses those electrons and becomes positively charged. Next is to say that, let's say the balloon was negatively charged, doesn't matter which one you choose, it has a charge, and you were bringing it towards the water, your neutral water. As you bring that negatively charged thing towards your neutral water, you induce a charge in your water. That's because all of the electrons in your water near that balloon get repelled by that negative charge on your balloon, and therefore leave behind a little bit of positive charge on the water. Negative charge on the balloon, little area of positive charge on the water, they are attracted to each other. Okay, next question. Two insulators, a rod and a cloth, become charged when they are rubbed together. A pupil says the rod is positively charged because protons move onto it, and the cloth is negatively charged because electrons move onto it. Explain whether you agree or disagree with the pupil. Okay, well, firstly, disagree. And the reason is this mention of the protons. Your protons do not move. So whenever you're talking about something becoming positively charged, like the rod, you have to say it's because it must have lost electrons, not gained protons. Okay, don't mention protons throughout the whole of your electrostatics topic. So it's lost electrons, and the cloth is negatively charged because the electrons have moved from the rod onto the cloth, so the cloth has gained electrons and become negatively charged. Okay, next question. Explain why an object being attracted to another object is not sufficient to conclude that both objects are charged. So this is because you can have neutral objects that are attracted to charged objects because of this idea of being charged by induction. When you bring a charged object towards a neutral object, you will actually induce a little charge in that neutral object, just like our balloon and our water in that earlier slide. Okay, what's the real test then to see if two objects are charged? Repulsion would be the true test to see if something is charged, because neutral objects can only be attracted, they can't repel anything else. Okay, lightning rods are metal rods on buildings used to direct lightning to the ground. Explain how this works and why lightning strikes in the first place. Okay, so a metal rod, what is metal very good at? It is a conductor, and that means that it can provide an easier route for charges to flow down to Earth. You get a flow of charges in the first place because you have to say there is a potential difference between the clouds and the ground. So that potential difference causes this spark, which is just actually a flow of electrons between the cloud and the rod, and then because the rod's a conductor, that takes the electrons down to Earth. So why does lightning even strike in the first place? Remember, to have static electricity to cause this spark, it is because you must have some kind of potential difference between charged clouds. So clouds moving over each other provides the friction, and they rub electrons or transfer electrons between each other to give you that potential difference between the clouds and other clouds, or the clouds and the Earth. Okay, explain why earthing a car while spraying it with a positive charge spray is most effective for a well-covered car. So firstly, let's talk about the positive charge spray. Remember, if all of those little paint droplets have a positive charge, then you all have like charges, and those like charges repel each other. So all your paint droplets spread out from one another to give you a nice even mist. Then, if we have a think about earthing the car, when that spray comes towards your car, what you do is you induce a charge in your car. The electrons flow to the car from the earth because they're attracted by this positively charged paint. And then you have a negatively charged car and some positively charged paint, and opposites attract, so the paint sticks to your car. Okay, explain why it's important to discharge a plane before refueling. What is a spark? So the point of discharging a plane, what we mean by that is to get rid of charges. So if you have less charges built up, you have less of a potential difference between the plane and the ground. Remember, it's your potential difference here that really causes sparks. So you have less chance of those electrons flowing in a spark, and that's good because otherwise you could cause a fire whilst you're refueling. Spark, just a flow of electrons. Okay, what does the field between two unlike point charges look like, and explain how the diagram shows me the properties of the field. So you need to know that this is what the field looks like. Because they are point charges, around them they have this almost like spider web pattern, and between them, right between in the middle, you might have some parallel lines, but they kind of bound out round, curve round a bit. It looks a bit like a bar magnet. You need to learn all of your different electric field patterns. You need to know that your arrows go from positive to negative. Okay, so that's something that the diagram is showing here. And you need to know that the higher concentration of your lines indicate a stronger electric field. Yeah, the arrows as well, because they go from positive to negative, that's the convention. What they're showing is if you put a little positive charge somewhere in that field, those arrows would show you the direction of the force on that positive charge. Let's say I put it in between, a little positive charge in between the positive and negative. It's going to be repelled from the positive and attracted to the negative at the same time, and it's going to go off towards the right here.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Some tips and tricks this section. So first one, using key kind of buzzwords. So talking about earthing when you are trying to discharge something, talking about the reason that you'd get a spark is because of a potential difference between a charged thing and the earth or another charged thing. And whenever you're talking about static electricity and how these charges build up in the first place, mention via friction. Electrons being transferred via friction is very important. Uses of electrostatics, make sure you mention two things if they apply. So for example, with spraying the car, one thing is a fine mist, so why you would have all of paint with the same charge. And then the other thing is less waste, okay, so the idea that it would stick to your object as well. Enough field lines, yeah, make sure you have probably at least 3 field lines, probably a lot more than that, but definitely 3 for a uniform field. And check that your arrows are in the correct direction, so from positive to negative.